everyone, I'm Luziyu Sophie from 科技系一期 TAHRD 117. Today I'm going to show you how to design a gearbox. First, let's bring the motor into our view. Go to the top left, click Place, select your motor file, and click OK to load into the assembly. To take it look better, change the visual style on the right and shade it with edges. Now, click Create on the top left to make a new part within the assembly. The default unit is inches, so remember to change it to millimeters. Make sure to save it in the correct folder and give your part a name. Click on the empty space, select the XY plane, and right-click to select New Sketch. We need a square plate for the motor. Choose rectangle from the toolbar and pull it outward. You can type the number directly to set the size. Double-click any dimension to change it. Once finished, click Finish Sketch and use Extrude to make it 3D. Adjust the thickness as needed. Right-click and select Measure to check the motor shaft diameter. Go back to your plate, start a new sketch on the face, and draw a circle. Set a center-to-center distance to 60 millimeters. Use project geometry for the XY axis and add dimensions. If the lines are purple, it means they are under constraint. You can drag the line to see what is missing. When ready, click Extrude. Choose the cut direction to remove the material. Now, right-click, constraint to align to the motor shaft with the hole. Select the shaft and then the hole, then click Apply. Now, we need a hole for a large gear, 45 millimeters away from the motor hole. This ensures the gears match correctly. After extruding, let's create the extra gears. Go to the Design tab and select Spur Gear. Here you can adjust the module and number of teeth. Click OK and Accept. These are placeholder gears, so we need to right-click and select Export to strap to make them real. For the small gear, use Extrude and then circular pattern to create 15 teeth. We also need an 8 mm hole into the center for the motor shaft. Right-click and toggle visibility to hide sketches you don't need. Always remember to save your work. Place the gear into the assembly and constrain it. Repeat the steps for the large gear, but change the tools count to 45. For the large gear, we will use a bearing. Measure the bearing's inner diameter, update your sketch, and use constraint to fit them together. Adjust the offset in the constraints to keep some distance between parts. To make the gear move, right-click Constraint and go to the Motion tab. Select Reserve Rotation. Click both gears, and now they will turn together. Use another constraint to make sure the motor doesn't move back and forth. For better grip, I'm changing the shaft hole to a hexagon shape with a size of 12.7 mm. Next, create a new part for the shaft. Measure the distance in the assembly to get the size right. Once done, assemble the shaft gears and bearing and bearings. If the shaft is too long, just go back into the sketch to edit it. Now we need to test the dimensions repeatedly in the assembly to make sure all parts fit together perfectly. Now, let's add the motor squares. Start a sketch on the plate. Use project geometry on the motor's hose and extrude. Use the joint tool to square the fasteners into the holes. For the plate squares, draw 5 mm holes, then go to place from content center. Select a 40 mm square and choose as custom so you can save it in your project folder. Finally, we will add a spacer to protect the squares from bending and a bushing on the shaft to keep the gear from sliding. This completed the gearbox. That's all for my project. Thank you for your watching.